Hi guys, in today's video we are going to see a polynomial hierarchy, a hierarchy of complexity classes that generalize most complexity classes including P and P CoNP to Oracle machines and all others. This hierarchy is known as PH for short. But before getting into the action, let's match our expectations. My videos depend on the wisdom of the crowd, a topic that really fascinates me. Since I'm studying this topic by myself, there might be an occasional mistake in what I say. Please correct me in the comment section below. I promise to read all comments and re-upload if necessary. Together we can answer tough questions in a better way. Also, please subscribe to my channel. I tend to upload many videos on this topic. To understand the notion of the polynomial hierarchy, we would look at some terms and also compare it to a made-up new polynomial hierarchy, which we would prove is equivalent to PH. Let's get right into it. Alrighty, complexity classes. The complexity class P contains all decision problems that can be solved in a polynomial computation time using a deterministic Turing machine. The complexity class NP, a class of decision problems where given an input we can determine in a polynomial time if the input satisfies the problem using a deterministic Turing machine. CoNP, a class for all opposite problems to problems in the complexity class NP. Such problems might be in the NP class as well, so the intersection of the complexity classes NP and CoNP is not an empty set. But the question of is NP equals CoNP is an outstanding question in the field of computer science. We learned about the vertex cover problem, for example, and we saw it is in NP. The opposite problem to the vertex cover problem is, does the graph does not has a vertex cover of the size of the given integer k? Using a reduction, it is easy to prove this problem is in NP, but since its opposite problem is in NP, this problem is also in CoNP. The complexity class sigma k, decision problems that require k-truth functional operators and start with a logical disjunction. Cos sigma k equals pi k. Pi k, decision problems that require k-truth functional operators and start with a logical conjunction. Co pi k equals sigma k. NP to the power of pi k, class of decision problems that can be solved using a non-deterministic Turing machine, with an Oracle access to problems from the complexity class pi k. It is worth mentioning that the complexity class sigma k equals NP to the power of sigma k minus 1. Complexity class of decision problems that are solved using a non-deterministic Turing machine with an Oracle access to problems from the class sigma k minus 1. Polynomial hierarchy. The polynomial hierarchy is a hierarchy of complexity classes that include the complexity class P at the bottom of it, followed by NP and CoNP to Oracle machines. PH equals the disjunction of k equals 0 all the way to infinity of sigma k. We will soon see how it looks. Is P equals NP? This is a major unsolved problem in computer science. As a matter of fact, it is one of 7 unsolved problems called the Millennium Prize selected by the Clay Mathematics Institute of New Hampshire. Carries a prize of $1 million. Although the problem is unsolved, the common assumption is that these classes are not identical. If they are, however, the polynomial hierarchy collapses to its base level. It is known, however, that NP is not a subset of P. In other words, NP is either identical or bigger than P. Assuming that P is not equal to NP, the hierarchy looks like that. As you can see, every complexity class is a subset of the next class on an increasing order. So, for example, P is a subset of NP and CoNP. All 3 complexity classes are subsets of sigma k and pi k, but pi k and sigma k are not identical, and so forth. To understand the notion of the polynomial hierarchy better, we would create a new hierarchy and prove both the classic polynomial hierarchy and the made-up hierarchy we are about to see are equivalent. We would define a new polynomial hierarchy, ph prime, in the following way. Sigma 0 prime equals pi 0 prime equals b. Pi k prime equal co sigma k prime, and sigma k prime equals np to the power of pi k minus 1 prime for every k bigger or equal to 1. ph primes equals the disjunction of k equals 0 all the way to infinity of sigma k prime. We would prove that ph primes equals ph by induction on k, base of the induction. Sigma 0 primes in ph prime equals sigma 0 in ph equals p equals pi 0 primes in ph prime equals pi 0 in ph, which of course is true. Now, before proceeding to the hypothesis of the induction, we would make a claim. np to the power of sigma k equals np to the power of pi k for any k bigger or equal to 0. To prove this claim, we would assume that some problem S is in np pi k and prove that S as a result must be in np sigma k. Then we would switch roles. From the assumption that S in np to the power of pi k, we know that there is a polynomial non-deterministic algorithm with an oracle access to some problem S prime in the complexity class pi k. We would call this algorithm C. We would see that there is a polynomial non-deterministic algorithm with an oracle access to a problem in the complexity class sigma k. We saw that the class co pi k equals sigma k and vice versa. So according to the assumption that S prime is in class pi k, the complement problem S prime with overline is in sigma k. We would define algorithm D in a similar fashion to algorithm C we had mentioned above, except to the way of the algorithm to ask the oracle questions. It would ask non-membership questions of the complement of S prime. Because such questions are identical to membership questions to S prime, the questions of both algorithms are the same. Also, because the algorithm D asks S prime with overline a question, it has an oracle access to sigma k. Therefore, np pi k is a subset or equal to np sigma k. The second direction is symmetrical. Hypothesis of the induction. Assume that for every k, sigma k equals sigma k prime and also pi k equals pi k prime. Step of the induction. We would prove that sigma k plus 1 equals sigma k plus 1 prime and pi k plus 1 equals pi k plus 1 prime. So sigma k plus 1 prime equals to np pi k prime from definition, and it equals to np pi k from the induction hypothesis, which equals to np sigma k from the claim we had just seen, and this equals to sigma k plus 1, which is known. So the definition for ph prime can be written as ph prime equals the disjunction of k equals 0 all the way to infinity of sigma k, which is exactly the definition of ph. Therefore, ph equals ph prime. Well, that's about it. I hope you learned something new from this video, and please comment below with your thoughts. First degree studies in university are all about social studies, and this project comes to encourage that. Please subscribe to my channel. Until next time, good luck.